Hi everyone, welcome back. So far, we've learned how SQL Server stores data in pages, how indexes help reduce page reads, and how B-trees allow SQL Server to navigate efficiently through those indexes. But over time, something happens that slowly reduces the efficiency of those indexes. That problem is called fragmentation. Before understanding fragmentation, let's first understand the meaning of the word itself. The word fragmentation comes from the word fragment, which simply means a broken piece of something that was originally whole. Imagine dropping a glass on the floor. Instead of one complete object, you now have many small pieces scattered around. The same idea applies to databases. Ideally, SQL Server wants related data to be stored neatly in continuous pages. But as data changes over time, those pages become scattered and broken into pieces. Instead of one continuous sequence of pages, SQL Server now has to jump between different locations to retrieve the data. That scattered arrangement is called fragmentation. Fragmentation doesn't happen overnight. It naturally occurs as applications keep inserting new records, updating existing records, and deleting old records. Every business application, including D365 Finance and Operations, performs these operations continuously. As a result, fragmentation slowly increases over time. The more fragmented an index becomes, the more work SQL Server has to do to read the required data. And more work usually means slower queries. There are two main types of fragmentation. The first one is internal fragmentation. Internal fragmentation refers to wasted space inside a data page. Remember that each SQL Server page is 8 kilobytes in size. Ideally, we want that space to be efficiently utilized. Suppose a page originally contained several rows. Later, many of those rows are deleted or updated. Now the page may contain only a small amount of data while the remaining space stays empty. For example, imagine an 8 kilobyte page where only 3 kilobytes are actually being used. The remaining 5 kilobytes are simply wasted. SQL Server still has to read the entire page even though most of it is empty. That is called internal fragmentation. The second type is external fragmentation, also known as logical fragmentation. This is usually the more important type when we talk about index performance. Imagine SQL Server expects to read pages in the order page 1, page 2, page 3, and page 4. But because of continuous inserts and updates, the pages are now physically arranged like this: page 1, page 4, page 2, page 3. Although the logical order of the data is still correct, the physical storage is no longer continuous. SQL Server has to jump between different locations while reading the index. Those additional jumps increase physical I/O and reduce performance. Let's understand this using a simple sales line example. Suppose we have a clustered index on the sales ID column. Initially, new sales orders are inserted sequentially. The pages contain SO-1001, SO-1002, SO-1003, SO-1004. Everything is nicely ordered. Reading the data is fast because SQL Server moves smoothly from one page to the next. Now imagine SO-1002 is deleted. Later, SO-1003 is updated and becomes SO-2005. As more inserts and updates happen, SQL Server may have to move rows to different pages because the original pages no longer have enough space. Instead of continuous storage, the data becomes scattered. This scattered arrangement is fragmentation, and the more scattered the pages become, the more page reads SQL Server performs. Fortunately, fragmentation can be measured. SQL Server provides a dynamic management view called sys.dm_db_index_physical_stats. This view allows us to check every index and see exactly how fragmented it has become. For each index, SQL Server provides useful information such as the index name, the fragmentation percentage, and the total number of pages used by that index. Once we know the fragmentation percentage, we can decide what action should be taken. If fragmentation is less than 5%, it is considered normal and usually does not require any action. If fragmentation is between 5 and 30%, SQL Server recommends reorganizing the index. Reorganizing is a lightweight operation that rearranges the existing pages into a better order without rebuilding the entire index. If fragmentation is greater than 30%, rebuilding the index is generally the better option. A rebuild creates a completely new, well-organized index, eliminating fragmentation and restoring efficient page ordering. However, there is one important point for D365 finance and operations developers. If you're working in a cloud-hosted production or sandbox environment, you normally don't perform index maintenance yourself. Azure SQL Database and Microsoft automatically monitor and maintain indexes in the background. This includes rebuilding indexes, reorganizing indexes when necessary, and updating statistics. So, in production environments, fragmentation maintenance is largely handled automatically. However, if you're working in a Tier 1 development environment or an on-premises installation, you have full access to SQL Server. In those environments, you can manually check fragmentation, analyze the results, and rebuild or reorganize indexes whenever necessary. We'll see exactly how to do that in the practical section of this course. The key takeaway from this video is simple. Fragmentation means that index data is no longer stored efficiently. Internal fragmentation wastes space inside pages. External fragmentation scatters pages into an inefficient physical order. Both increase the amount of work SQL Server performs while reading data. Understanding fragmentation helps us understand why database performance slowly degrades over time and why regular index maintenance is an important part of database optimization. So, I'll see you in the next video.